It's 11 o'clock at night. I should be in bed, not making videos for you guys, but I got a lot of work to do this weekend, so I'm hoping to get some of these knocked out. www.nkinfinity.com is where you can find this. This is my lunch review day number 3. Now, right now, these aren't on here, but if you go here and you click on New York State Teachers in Review, by the time you probably see these videos or you try these ones, they'll be down here at the bottom, and I'll call them lunch reviews. And there's going to be at least 8 plus a bunch more. I'm going to be doing a bunch more review during the final week. So lots of stuff to study from, all right, kids? Let's get started. Now, I decided to start out the probability, not with necessarily problems, but with all the formula that you have to know. These will not be on your formula sheet. You have to know these. If you see the word or, this is the big one, you're going to write this equation every single time. Probability of A or B is equal to probability of A plus the probability of B minus the probability of A and B. If you see that A and B are independent, that's what this means. Or you could say that the probability of A and B is equal to the probability of A times B if they're independent. If they're not independent, then you got to use this formula. The probability of A and B is equal to, now look at this. If I just start this out, that's the independence formula, right? But then you got to add a little piece. So its probability is equal to this or this one. Notice, as you're doing these, B matches B, right? This right here is the independence formula. And then you tag on B. This right here is the independence formula, and you tag on A. And I'm going to be doing a couple examples with these formulas. Let me get rid of them so I can come back to them when I need them. And then if you want to test for independence, these are the 2 tests for independence. The probability of A is equal to the probability of A given B. Or the probability of B is equal to the probability of B given A. Or you can show that their products are equal. If events A and B are mutually exclusive, the and, or the probability of both happening at the same time, is 0. All right, let's get going. We're definitely going to be using the heck out of these formulas, so make sure you have them down or next to you so you can view them. Given events A and B such that the probability of A is 0.4 and the probability of B is 0.3, find the probability of A or B. So there it is, right there. Boom. So, no, it didn't say find the probability. It gives you this. But do you see the or? As soon as, remember, this is an or. As soon as I see the or, as soon as you see the or formula, this one, has to be written. So the probability of A or B is equal to the probability of A plus the probability of B minus the probability of A and B. Okay, so this is 0.65 is equal to the probability of A, 0.4, plus the probability of B, 0.3, minus this thing, which I don't know what it is. So if I solve this, I get negative 0.05 is equal to negative probability of A and B. All I did was bring the 0.4 over and the 0.3 over. Or the probability of A and B is equal to 0.05. Well, that doesn't tell me if they're independent or not. I got to use this test for independence. And this one test for independence is right here. If they're independent, then the probability of A and B is equal to the probability of A times the probability of B. So let's see what would happen if they are in fact independent. The probability of A and B would equal 0.4 times 0.3. Well, 0.4 times 0.3 is 0.12. Since 0.05 does not equal 0.12, they are not independent. So I had to use 2 of those formulas, 2 of those ideas to see if these were independent or not. This is funny. The probability of Coach Lapani changing his seat during a basketball game is 0.9. So the probability of Lapani is equal to 0.9. The probability of Joey Lapani getting 16 minutes of playtime is 0.75. So the probability of Joey is equal to 0.75. The probability of Coach Lapani moving his seat and Joey is getting playtime over 6. So the probability of Lapani and Joey is equal to 0.675. It can be concluded that the two events are, well, if they were mutually exclusive, remember, mutually exclusive means the and is equal to 0. So if they are mutually exclusive, the and would be equal to 0. Since it's not, they're not mutually exclusive. If they were complements, you can't really have complements of this. Complements would be like the probability of rain, probability of not rain. So they can't really be complements. But even if they were, they'd have to add up to 1. They don't. So now we either got to test for independence, or if they're not independent, they got to be dependent. Well, the fast test for independence is the probability of Lapani and Joey equals the probability of Lapani times the probability of Joey. If they're independent, that has to be true. So let's check it out. 0.675, does that equal 0.9 times 0.75? Now it has to be exact, so come over to your calculator. And we're going to do 0.9 times forgot what the other number is, 75. Oh, 0.675. So 0.675 equals 0.675. So they are, in fact, independent of each other. So that last problem was for you, Coach Lapani, because we know you love to move your seat during those games. Drive me crazy. Anyway, and the crazier the game, the more seat movement we get. Anyway, the probability of Miss Lang coming to my review class is 0.4. So the probability of Lang is equal to 0.4. The probability of Mr. Cedia coming to review class is 0.34. The probability of Miss Lang coming to review class, given that Mr. Cedia has come, is 0.85. So basically, I got to check to see if these, it's hard to tell if they're mutually exclusive. That's hard to actually tell in this case. But I can test for independence. I can check to see if they're independent, because if they're not independent, they're definitely dependent. And if they're dependent, they're certainly not mutually exclusive. So we got to test for independence. And our test for independence is, if we go back up here, I can either use the and, but it didn't give me any and stuff. So I can't really use that. But if the probability of A is equal to the probability of A given B, if those are equal, then it's independent. So I'm going to test to see if the probability of Lang is equal to the probability of Lang given Cedia. Well, is 0.4 equal to 0.85? Absolutely not. So they are not independent. Therefore, they must be dependent on each other. I guess, wait, hold on. I guess if they were dependent, I guess they could be mutually exclusive, but they're not. Let's get rid of it. The math department had to report out to the Board of Education about students enrolled in higher level math course. Made this up. The report indicated that 18.4% of the senior class were enrolled in AP Calc. 12.4% of the senior class was enrolled in stats, and 3.6 were enrolled in both. So let's get our information down. Probability of calc is 0.184. The probability of stats is 0.124. And the probability of calc and stats, that's enrolled in both, is equal to 0.036. All right, so what's the question asked? Find the probability to the nearest hundredths place that a student enrolled in calculus, that a student is enrolled in AP Calculus given they are enrolled in AP Statistics. So what is the probability of calculus given statistics? What you talking about, Wes? How are we going to do this problem? Well, I didn't tell you whether or not they're independent or not. So if they don't tell you that they're independent, I got to use one of my dependent formulas, right? These are one of my dependent formulas right here. I didn't tell you whether they're independent or not, so I got to use one of those. And those formulas are simple. They are, in fact, the probability of calculus and stats is equal to, remember, you're going to write the independent formula and then keep writing. So it's the probability of calculus times the probability of stats, that's the independent, given calculus. Or that's equal to the probability of stats times the probability of calc given statistics. Now, what are we looking for? We're looking for this one, and that's in here. So in order to figure out what this is, I got to use this one and this one. So I need this and I need this. So how are we going to do this? So I know probability of calculus and statistics. So we're not going to use this formula. So this is equal to 0.036 is equal to, what's the probability of stats? 0.124 times the probability of calculus given stats. And I just divide by 0.124, divide by 0.124, and I'm done. But the key was I had to use that formula in order to do it. And I used it because I didn't know if they were independent or not. I wasn't told yay or nay. So 0.036 divided by 0.1, I forgot, 24. And 0.29, did I tell you we're at around hundreds place? So the probability is a decimal, not a percentage. So the probability of calculus given stats is equal to 0.29. Explain to a board member that may or may not understand statistics what this means. Well, what this means is there is a 29% chance. There is a 29% chance. Let's write it out. Let's see if I can write this neat. There is a 29% chance that if we select a student that is in an AP stats course, they will also be in AP Calc. So it's not 29% of the seniors are in AP Calc. It's if we go into the stats class and we select a random stats student, there's a 29% chance that they're also in AP Calc. Done. All right. Events M and N are known to be independent. Okay, guys, right there. Boom. Let me get some stuff down. As soon as I tell you they're independent, I know three things. The probability of M is equal to the probability of M given N. I know that the probability of N is equal to the probability of N given M. I also know that the probability of M and N is equal to the probability of M times the probability of N. That is incredibly important. As soon as I tell you they're independent, I know those three things. They have to be true. Okay? So let's go back to the problem then. I'll try to keep that stuff off to the side. Can't do it. So you have to remember what I just wrote. Hopefully you just wrote it down. So what does that give us? Well, let's look at this. The probability of N is 0.35. The probability of M given M is 0.4. But wait a second. If they're independent, then doesn't the probability of M equal the probability of M given N, which is equal to 0.4? So I know that the probability of M is 0.4. What is the probability of M or N? Whoa, I see the or. As soon as I see the or, I got to write the or formula. So probability of M or N is equal to the probability of M plus the probability of N minus the probability of M and n. Well, let's see what I know. I know this. I know the probability of m now is equal to 0.4. I know the probability of n is 0.35. But do I know this? Wait a second. If I have independence, don't I know this? I know that the probability of m and n is just the product of the two if they're independent. So this is minus 0.4 times 0.35. And that's what you got to put in your calculator. Once you know that, then it's pretty easy. 0.4 plus 0.35 minus 0.4 times 0.35. 0.61. There it is, 0.61. Bodied. Anybody say that dumb thing in your school? Man, do I love these two-way tables. They are so simple. They're nice and easy, like free points. If you remember a few things. First of all, if the totals aren't here, you got to come up with a total. So in this case, I gave you the totals because I didn't want to waste your time. But if I don't give you the totals, you got to come up with them. So what is the probability of on time? Well, how many are on time? 112 out of 200. That's it. Done. Man, that was simple. Now the problem says, what is the probability the bus is delayed given it occurred in July? Well, if it occurs in July, then you are not allowed to look at anything but July. That is all. I can pretend like the rest of it doesn't exist. Cover it up. It is completely useless. So what is the probability that it's delayed given they're in July? Well, how many were in July? 79. So in this case, it's 35 over 79. So the next question says, is R being delayed and the month of June independent? Well, this is an easy test. I just got to test it once. Does the probability of June equal the probability of June given, what is it, delayed? If it's true, if that's true, they're probably independent. Maybe I want to test one other thing. If it's not true, then they're not independent. Well, the probability of June is 63 out of 200. The probability of June given delayed. Now, wait a second. Given delayed means I'm only allowed to look at delayed. So there it is. The probability of June given delayed, let's see, June given delayed is 23 out of 88. Well, I'm not sure if those are equal, so I'm going to just go over my calculator. 63 divided by 200. Oops, 63. I think it's 0.31. 63 divided by 200, 0.315. I meant 0.315. So this is 0.315. Does that equal that 0.26? Man, that's pretty close, but nope, not independent. And there's my work. All right, moving on. Given events S and M such that the product of S is equal to that, the product of M is equal to that, the product of S and M. Oh, wait. Or, I have an or. Alert, I have an or. So if I have an or, I got to write it down. Probability of sum, S and M, S or M, is equal to probability of S plus the probability of M minus the probability of S and M. Let's see what I know. I know this is 0.94. I know this is 0.33. I know this is 0.61. I don't know this, but I can solve for that. So, I get, if I subtract this over, I get 0 is equal to negative probability of S and M. Or just 0 is equal to probability of S. So that means they're mutually exclusive, which means they are not independent. They are certainly dependent. Moving on. This is the last question. Oh, I got 2 questions left. This one's tough. This one's kind of tough. Here, once again, I've got my OR, so I want to go the probability of H or M is equal to the probability of H plus the probability of M minus the probability of H and M. So we want to find the probability of M if H and M are mutually exclusive. Well, if H and M are mutually exclusive, this is 0. The probability of H and M is 0. If, why did that stupid thing come up? If this comes up, if they're independent, the probability of H and M is 0. So this just kind of goes away. So therefore, it's an easy problem. The probability of H or M is equal to this. Well, this is 0.56 is equal to 0.45 plus the probability of M. So if I subtract, I get the probability of M is equal to 0.11. Okay. Now, this one's a much, much more difficult question. I know that this is I'm going to use that same formula. The probability of H or M is equal to the probability of H, which we know, plus the probability of M, which we're looking for, minus the probability of H and M. However, if they are independent, then what is the probability of H and M? Isn't the probability of H and M really just the probability of H times the probability of M? If they're independent, then that's the truth. I know that those two products have to equal the probability of H and M. So I can replace it. I'm going to replace it. Just like I replaced this with a 0, I'm going to replace this with that formula I know. All right, let's put the stuff in. 0.56 is equal to 0.45 plus the probability of M, I don't know that, minus 0.45, because I know that, times the probability of M. Well, I can move this 0.45 over, and I get 0.11 is equal to, now here comes the tricky part. This is 1 probability of M minus 0.45 probability of M is really equal to 0.55 probabilities of M. Oh, okay. Because this is like 1x minus 0.45x. It's 1 probability of M minus 0.45 probability of M is this. So now I just divide by 0.55. And I think that's just 0.2. So 0.2 is equal to the probability of M. Woo, man. One last problem, kids. Here we go. Let's go. Let's get this one done. This one won't take long. This one's actually pretty easy. Last one's the easiest one. Probability, there are currently 355 seniors in our building. So the probability of being a senior is 355 over 2 grand. We got reported that there's 280 parking passes in the building. So the probability of a parking pass is equal to 280 over 2,000. And the probability at random, a senior or has a parking pass, so the probability of being a senior or having a parking pass is equal to 461 over 2,000. Now, I wrote an OR, kids. As soon as you write an OR, you have to write the OR formula. The probability of senior or parking pass, sub, that's like what's up, is equal to the probability of senior plus the probability of parking pass minus the probability of senior and parking pass. All right, almost done. Get all the hard part done. Probability of senior or parking pass is 461 over 2 grand. The probability of senior is 355 over 2 grand. Plus the probability of parking pass, which is 280 over 2 grand. So the only thing I don't know is this, the probability of S and parking pass. Well, this is 461 over 2,000 equals 355 plus 280, 635 over 2 grand minus the probability of S and parking pass. So I take the 4, doggone it, I always do that. 461, I'm going to subtract off the 635, and I get negative 174. So negative 174 over 2,000 is equal to negative probability of S and parking pass. Well, I don't need the negatives, so there it is. Divide both sides, and there's my answer. Oh my gosh. Woo! That's 6 videos tonight. It's 12:30 or 11:35. Finished almost on time. Okay, kids, hit the subscribe button, hit the like button, tweet, text, tell your friends, tell everybody you know. Hey, lots of cool stuff for review. Hopefully it's helpful. All I want is for you guys to crush the Regents exam. I don't care about anything else. I don't care who you are. I don't care what school you go to. I don't care where you are in the world, what math you know. I just want to help you crush the math exam. I want you to tell New York State, I can crush the Algebra 2 exam. Bring it on, baby. Bring it on. All right, guys. Catch you all on the flip side. Bye. Oh, bye. You got to go. I got to go to bed. Goodbye.